Let us position an object in front of an observer at the eye level and in the midplane of the head. If the eyes are properly aligned and the object is fixated binocularly, an image will be received on matching areas of the two retinas. If the two eyes are functioning normally, the two images will be in the same size, luminance, and color. In spite of the presence of two retinal images, only one visual object is perceived by the observer. Whenever a retinal area is stimulated by an image, the image is perceived as being localized in a certain direction in the visual space. If the stimulated retinal area is located to the left of the fovea, the object is seen in the right half of the field. If it is located to the right of the fovea, it is seen in the left half of the field. The appearance of an object in the periphery of the visual field attracts attention, and the eye is turned toward the object so that it will be imaged on the fovea. A signal from the retinal periphery transmits to the brain the peripheral direction of the object. Corresponding impulses are then sent to the extraocular muscles to perform the necessary ocular movement needed to put the image onto the fovea. Each retinal element has a retinomotor value. This retinomotor value of the retinal elements increases from the center toward the periphery. The retinomotor value of the fovea itself is 0. The fovea is the retinomotor center, or the retinomotor 0 point. The retinomotor value makes it possible to measure ocular deviations by means of the prism and covert test. Corresponding retinal elements are those elements of the two retinas that give rise to the sensation of the same visual direction. Sensory correspondence is the unification of visual excitations of the two corresponding retinal images, into a single visual image. The simultaneous stimulation of non-corresponding retinal elements by an object, causes this object to be localized in two different visual directions and appears double or in diplopia. Motor fusion is the ability to align the eyes to allow the sensory fusion to be maintained. The stimulus for the motor fusion is retinal disparity outside Panem's area. Motor fusion is the exclusive function of the extrafoveal retinal periphery. In motor fusion, the two eyes are moving in opposite directions. When dissimilar images are presented to corresponding retinal areas, fusion becomes impossible. This phenomenon is termed binocular rivalry. Binocular rivalry may be produced by different color and unequal luminance of the two targets. Simultaneous stimulation of corresponding retinal areas by dissimilar images gives rise to conflict and confusion. One of the two images is temporarily suppressed. The horopter is the locus of all object points that are imaged on corresponding retinal elements. Panem's area of single binocular vision is a narrow band around the horopter. In Panem's area, stimulation of disparate retinal elements transmits the impression of single vision. Put your finger at reading distance in front of your head, and in its midplane. Select an object at infinity in the line with your finger. Fixate the more distant object. Your finger will be seen double. Fixate your finger. The more distant object will be seen double. This is a physiologic diplopia. Stereopsis is the relative ordering of visual objects in depth, that is, in the third dimension. Object points having a constant size appear to subtend smaller and smaller angles as they recede from the subject. Configurations in which contours are interposed on the contours. An object that interrupts the contours of another object is generally seen as being in front of the object with incomplete contours. Since sunlight comes from above, we have learned that the position of shadows is helpful in determining elevations and depressions, that is, the relative depth of objects. If the size of two objects is known, one can judge the relative distance of these objects by their apparent size.